Trunnions and lugs are used to lift and position vessels to their final location. Let's understand how to model them in both a horizontal and a vertical vessel and what check-ins are required in their analysis. Welcome to the lifting chapter. In auto-by vessel, there are three types of lifting accessories. Trunnions, with or without a swivel lug, lugs without gusset that can come in different shapes, and finally lugs with gusset that can take some shear load. The fact that the group in the middle, the lugs without gusset, cannot take shear load will condition the configurations you can make with them. In horizontal vessels, trunnions and lugs with gusset come in four, while lugs without gusset must come as a pair perfectly aligned to avoid shear loads. Vertical vessels allow more variety. First, you have lugs located on the head. They can be at the top, rotated or not, or even at both sides. Then you can have a pair of lugs like arms, one at each side. Please notice that you can always add a tailing lug to lift a vessel from its horizontal position to the vertical one, and depending on your configuration, there can be up to 2 tailing lugs in one same design. Let's do an example of 4 lifting lugs with gusset on a horizontal vessel. We double-click on the saddle, and in the last tab we have the lifting accessories tab. First, we can choose the type of lifting accessories that we want to work with. Let's choose a lug C that has some gussets so that we have 4, as you see in the picture. The position of the first one is going to be 500. The distance of the second pair, separation between the second pair and the first one is going to be 5 meters. The orientation is going to be 135 degrees and 35 degrees. Then here I have angle A. I can click on the question mark to see what A refers to. We are in this case. So let's put 60. Use the question mark to understand any field and keep an eye on the image below while you input the rest of information. Then I will add a rectangular pad. Here you have the loading factor. This is the majorating factor of the weight. By default, we have 1.5. You can, of course, change it. And material, you can add different material for the logs. I just say OK. And you can see that my logs have been created and appear in the 3D. Now, be sure to have your load lifting case activated. So I go to the general properties by double clicking on the white background, load conditions lifted, and I activate it, and OK, and I just run calculation. Now in the tree of results, we can see lifting and show selected report calculation detail. You can see the equations on how the forces are calculated and distributed among the logs. Then the dimensions of that particular log, how the forces are determined, and then the checking of the well, the different sections of the log, calculation of the center of gravity, the stresses, and at the last part, we have the local loads analysis. We have this same report for each one of the loads. Now let's try a vertical vessel with trunnions and a tailing log at the anchor. We double click on the anchor. It could be also the legs or even the blankets. We double click, and in last tab, just as before, we can find the lifting accessories tab. We will choose a trunnion, the distance of the first one, the orientation. We're going to leave it that way. You can use a spreader min or not. And then we fill the dimensions of the trunnion itself and the pad also. We can change the local load method here, that it's independent from the openings. We can have 1 or 2 lifting lugs. And here you can see all the different possibilities in the help. So it's going to be located at the anchor, and then I just fill the rest of information. You can see my lifting log just here. I check that my lifting case is active, which it is, and I just run calculation. To open the results, we go to the tree of results and show selected report. Here you can see how the tailing log is acting with the two main trunnions here. And this is the final phase of the lifting, where it's vertical and we are just positioning it. Here you can see how the different calculations between the tailing log load and the main accessories are calculated. Here you have the equation, and for the different angles of lifting, you have all the different calculations of forces and stresses. And here you have the biggest one. Then the image of the trunnion, the main accessory, the dimensions of it, the check-ins that we perform, and the well stresses. Then you have the local loads, according to WRC this time. And then the tailing log. This is the tailing log dimensions and different stresses and check-ins. And here you have a graph of the bending moments and shear forces along the lifting. And this is it for a vertical vessel. Hope that you now get a much clearer view of lifting accessories and analysis. Thanks very much for watching, and remember to subscribe.